So this time we have a problem where we have two blocks. So we have block 1, so it is on top of block 2, and we have a rope, so the rope is pulling up on block 1, and then block 2 is sitting on a surface. So in this situation, we now have two different objects, so that means we're going to need to do two free body diagrams because there are two objects. So we want to do a free body diagram for every object that we are interested in. So otherwise, this situation is kind of similar to the last problem we did. Our block 1, we are given a mass. Block 2, we're given a mass, 1 kilogram. The rope is pulling up this time instead of a hand pulling down, and we're given the tension. And we're also told that these are resting on a surface, so that means that they are not moving. There is no acceleration. So, all right, let's go through our process to solve the remaining forces. So we're asked what is the force and the normal force on 1 by 2, and what is the normal force on 2 by the surface. So the way we start is by drawing our free body diagrams. So let's do our free body diagram for 1. So for 1, we have the weight force pointing down. Then we have two forces pointing up. So there is a normal force on 1 by 2 pointing up, right? So the block 2 is holding up block 1, and then also we have the tension force on 1 by the rope. So that gives us our three forces here. So this is for block 1, and we might as well do block 2 while we're at it. So in the case of block 2, notice we have normal force on 1 by 2, so that means we have a third law pair, so we have a normal force on 2 by 1, so that's pushing a block 2 down. Then we also have the pointing up, we have the normal force on 2 by the surface, and then, I almost forgot, we have our weight force, of course. Weight 1e is pointing down. Usually you do that one first. All right, so once again, we have three forces acting. This should be weight 2e, right? So this is the weight of our second block. So the point is that we have our three forces here. So so that means that we can then try and figure out what the missing forces are. Once again, like in the last problem, we have all of the forces are in the y directions. They're all up and down. There are no forces to the left and right, so we can really just consider forces in the y direction here. So the second part of our strategy here is to use the second law of motion to figure out the remaining forces. So that means the sum of the forces is equal to the mass times acceleration. So let's write down, let's start with block 1. So in this situation, we can solve block 1 more easily than we can block 2. The reason is, if we look at this, normal 2-1 and normal 2s are not so easy to find right now, whereas on block 1, we know tension 1r, we know weight 1e, so normal 1-2 is the only thing we don't know, so we can then solve for normal 1-2. So, okay. Let's do our forces here. So we have weight 1e. So this, we look at the block 1. Block 1 has a mass of 3 kilograms. So we can do that in our heads, I think. So it's 3 kilograms times 10 meters per second squared. So the weight force here is negative 30 newtons. The tension 1r. So this is given. So we are told that it is 15 newtons. So this is plus 15 newtons, and then our missing force here is the normal 1-2, and we don't currently know the answer to that, and then that is equal to the mass times acceleration. The block is at rest, so there is no acceleration, so the sum of these has to be up to 0 newtons. So that means that negative 30 plus 15 plus something is equal to 0, so we can then solve for that. So that means the normal 1-2 has to be plus 15 newtons. If we do that, it's negative 30 plus 15, and it's 0 newtons. So we've solved for this first part. What is the force on normal 1-2? Well, we found that it's 15 newtons. Now, the second part of the problem is to find normal 2s. And, I mentioned before, when we looked at block 2, there was a problem because we don't know normal to 1 and we don't know normal to s. So there's 2 unknowns, so we can't really solve this with one equation. Well, the thing is, we can now use the third law of motion because we know that normal 1, 2, so the force that block 2 is pushing up block 1 is 15 newtons. So that means the force that block 1 is pushing down on block 2 is negative 15 newtons. So we know that right away. So now the only thing that we don't know is normal to s. So we add up all of our forces here for block 2. So we have weight 2e, we've got normal to 1, and we've got normal to s. So for weight 2e, the block is 1 kilogram. So 1 kilogram times g, 10 meters per second squared, gives us 10 newtons, and it's pointing down. Normal to 1, well, we just solved this. So it is 15 newtons for 1, 2, so that means 2, 1 is negative 15 newtons, right? See how that works? If we know normal 1, 2, then normal to 1 is the negative of normal 1, 2. And then now for normal to s, we don't know that yet, but we know that if we add them up, that is equal to the mass times the acceleration. So again, our blocks are at rest, so that means that the mass times acceleration is 0, so the total thing adds up to 0 newtons. So we just have to solve for normal to s. So weight 2e is negative 10 newtons, normal to 1 is negative 15 newtons, and so that means how many newtons do we need to get to 0? Well, it has to be 25 newtons, so otherwise this doesn't all add up to 0. So we do that, and so that means we now have our number for normal to s. Okay, so that's the basic strategy. So the addition that we've done here is that now that we're using 2 blocks, what we do is we draw the free body diagrams for both, and then we pick usually the object on the top. We identify all the forces. We then set the sum of those forces equal to the mass times acceleration. Once we've done that, we can solve for the normal force between the 2 objects. And then if you know that, then you know, using the third law of motion, you know from normal 1, 2, you know the value of normal to 1. Okay, so I think you have a similar problem. I think it just doesn't have a tension force, but it's the same basic strategy, and so good luck with that.